Namaskar. Very warm welcome to all the viewers in this very special live interaction of CIET-NCERT. I am Renu Bhatt with you all, and you are watching us live on PM eVidya channels from channel number 6 to 12. And apart from all these channels, you are with us on our YouTube channels as well, that is NCERT Official and NCERT PM eVidya class number 6 to 12. And dear viewers, this is our very special 5 days online series for educators organized by aicell, CIET-NCERT, and the theme of the series is empowering teachers with artificial intelligence phase third. So we are on phase third right now, on phase 1 and 2nd. We have learned a lot about artificial intelligence, and the topic that we are going to discuss today in this specific session is machine learning for real world application 𝐸-𝐚𝐬. So what exactly machine learning is and how you can use that process in your teaching learning process. And we have joined by our expert to throw more light on this particular topic with a lot of information. Sir is Dr. R. Rajesh. You are professor from Central University of Kerala. Very warm welcome, sir. स्वागत है आपका. And before we begin this particular session, let me share some certain information to all the viewers out there. In case you have any query, you want to know more about machine learning, or you have an experience regarding machine learning, you can share it on our YouTube channel, or you can call us as well. Our telephone number is 8800 Either you can drop a mail as well with all your feedbacks and queries. Our email address is flashing on your television screen, that is aicell@ciet.nic.in. And in case you have joined us through our live streaming, then you have to go to the live chat box, and then only you can drop your comments out there. Our expert will be more than happy to answer all your queries and doubts if you have any. So artificial intelligence is very much important for all of us, especially in the field of education. So how you can utilize and you can get benefits of AI. So we are getting information, all this information in these particular series. So Rajesh sir, we want you to start this conversation. And what is machine learning and how is it beneficial for all the educators out there? So please explain to us, sir.
Yeah. So a very warm good afternoon to one and all present here. I am happy to be part of this online series on artificial intelligence for teachers, which is our phase 3 from 19 to 23. Today, what I am going to discuss here is especially on the topic of machine learning for real world applications, because this machine learning is going to change the entire world, especially in the education scenario. And in order to understand the working of machine learning, and also to make sure that teachers try to explain the machine learning in a right way to the students. So this phase of online series makes a very critical important for me also, so that this particular topic will reach the wide audience of teachers as well as the students. So my duty here especially is to make sure that I will be able to empower the educators to teach about machine learning for real world application. That is actually the motive for me to talk on this particular online series. And the simplest example that I want to quote you is shown on the screen, where the machine learning has reached each and every corner of the real life. For example, if you see here a particular equipment which is being enabled with machine learning, which is able to cut vegetables very faster than the normal human beings can do. There are robots which will play football like this. That simply means that there are systems available on behind of each and every robot sitting there, and inside that there are machine learning algorithms. And you see other type of robots which is playing football and all these things. So it means that each and every equipment in future that we use will have a part of machine learning embedded inside it, and this machine learning is going to support the human society in a great way. And this machine learning that we are talking about, as I told earlier, has so many applications inside: medical application, office automation, banking application, agriculture application, weather forecasting, like n number of things. Whatever you name it, you have the application of machine learning there. But this application, how they are using, what are the process by which a machine learning will work, what are the inputs that has to be given to the machine learning, those aspects I will be covering in the coming sections. So before going inside the machine learning, we need to understand where actually the requirement of machine learning starts. As you all know, we are in the world of computer era, where we use computers to convert the data into information by a process, something called data processing, that we all know it. But what we are trying to still learn is something called the conversion from information to knowledge, something called information processing step. There actually, without the existence of machine learning, we cannot convert this information to knowledge, because there are so many algorithms that we need to use it so that the information will reach the right person at right time and right semantics. It means that whenever we want to convey something to somebody in a right sense, for example, one of the person is standing on the edge of a road and a big vehicle is coming and going to hit him. And if we continuously say the information, a big lorry which is coming at a very high speed, which is white in color and going to hit you, and if you want to save yourself, you move back. We'll never say like that. Why? Because if we say like that, when the information reaches that particular person, the vehicle might have hit that particular person. So if you want to save that particular person, what we will say is actually we will talk in terms of certain language with high emotions. For example, move back. Okay, the word move back, just move back is not enough, with some emotional consent. So the person, when it hears the word, he will automatically move back. So a camera with a machine learning sitting on the edge of a road sees this particular incident and get all the information. But the information need to be converted into a format which the human society needs. The person who is standing there needs get an information with a high emotional content to move back from that situation, so that he will quickly move back, something is going to happen. So that conversion of information to knowledge, we need machine learning. Without machine learning, we cannot move forward. So it means that I will start with an example here. For example, you have a classroom where suppose the teacher is teaching something on the board. When we turn towards a blackboard, what will happen? Students will start talking in some of the classes. So when we want to monitor who is talking, who is not talking, then we need to have something called sensors inside the classroom, and these sensors will collect what is called as data. It can be cameras, digital cameras, or ultrasound cameras, or something called infrared cameras. So different types of cameras will be there which will collect the details about the students. It is not just like students who are talking. Certain students will have fever. Students will have might not have taken breakfast in the morning. Certain students might not be listening inside the classroom. They will be physically sitting in the classroom, their mind will be somewhere else. So these type of situations, if a teacher want to understand, because the situation, the entire educational scenario is changing like that, we need personalized attention. A student who has not taken breakfast and coming and sitting in the morning class, we know that how the student will be listening inside the class. Very difficult. If a student is having a fever or a problem on the eye, right, a red eye, then if you are not able to understand it properly, then it will create issues. If the student is not understanding what I am teaching, the facial expression itself will change for a student who is a good learner. So that facial expression, from the facial expression, whether we are understanding the student is learning or not. So different type of sensors will be there in terms of camera, in terms of temperature sensor, in terms of classroom conditions. These will measure the data. Whatever data is there, it will collect those data through a set of sensors. And these sensors will be collected in a platform. And these data, when it comes, there will be a set of softwares connected to these sensors, we call as device drivers. And these device drivers will collect the data and put it on the server. Then only we have a data. So where we get the data is very simple, that we have sensors, various type of sensors. From these sensors we'll get the data. It will be different information, can be facial information, will be talking information, it will be other information from the classrooms. Even I am speaking to the students, whether students are able to understand it, not able to understand it, whether I am telling something wrongly. whether the information that I convey to the students are wrong or not. Such type of thing also will become data. So whatever speech in my speech, students' questions, all the things will be collected as data. And these data has to be interpreted properly. For that, we need machine learning. So the machine learning part starts coming when you have a data on your hand. So the entire thing is that you need to have a data on your hand. This data will come from the sensors, and this sensor information will be collected as data on the server, and using this data only machine learning is going to work. And this machine learning, what it will do, it will make decision based on data. The important part of important duty of machine learning is to convert this data into some decisions. It can be moving, asking the student to ask the question if he is having his facial expression is different. The student might not have understood what I have told. So teacher can ask that, okay, the machine learning has given a warning that this particular student is having a doubt. Internally, his mind, we will not be able to read the mind, because nowadays certain students will not speak out. Certain students will not ask questions. So the machine learning is able to understand clearly and give an indication that this particular student is having some issues in understanding, or this particular student is his mind is somewhere else. He will be physically sitting inside the class somewhere else. So if this machine learning is able to give a decision, give a particular warning to the teacher that this is happening inside the classroom, then we will be able to manage the classroom in a much better situation. And thereafter, once the machine learning make a decision, we need something called implementation. For example, if the classroom temperature is very, very, very low and the students are shivering. Okay, students based on the fear of the teacher may not be telling. But if the machine learning is able to understand that based on the data that some students are shivering, the implementation, what it will do is automatically try to do adjustment on the ACs fitted on the classroom, or the fan that is fitted on the classroom. So many things. There are several type of implementation that is possible that will make something called actuations. So this slide, what I am trying to say is that the machine learning usage comes when we have data on your hand, and the machine learning duty is to make certain type of decisions, and these decisions further we want to apply on the system. And as I mentioned earlier, the clear definition, if we want to see, there are different types of definitions available for machine learning. So if you want to have one such definition, machine learning is a range of techniques whereby computers are trained to improve their performance by processing vast amount of data. The input to the machine learning is data from sensors, and machine learning will provide decisions. That is what the initial and the basic thing that we want to understand about machine learning. And in order to make a machine learning to learn, we need to have labeled data set. Labeled data set. What actually is the labeled data set? We will come to the next slide, where we say that suppose I want to make a machine learning to distinguish or classify this cucumber and banana. Suppose I have cucumber and banana. I want to create a small machine learning algorithm which will classify this cucumber and banana. Or suppose I want to make a machine learning algorithm that will clearly identify whether the students are talking inside the classroom, or whether I want to make a machine learning algorithm that identifies students are whether they are laughing. Like that. There's some small examples we can make it. But one machine learning made for one application may not work for other. So we have to create small application for each and every cases like this. And suppose we want to do like that. So we need to have so many cucumber images. Suppose my duty is to classify cucumber and banana. I need so many cucumber images, and I have to label it as this is cucumber. And I need to have so many banana images. I have to label it as banana. Suppose my duty is to classify talking inside the class. I need to have so many talking examples and so many non-talking examples. Suppose this is for laughing. I need to have so many laughing examples and so many non-laughing examples. So this is what is called as labeled data. We need to know whether this is a talking example, whether it is non-talking example, whether it's a laughing image or it's a non-laughing image. Like that, we need to have labeled data to make a machine learning to learn. Very important part. Okay, once we have this, then our duty, we have the label data, assume that we have the label data on hand, then our duty is to train the machine learning to predict whether it is cucumber or banana, whether they are laughing or not laughing, something like that. So step 2 is, most of the time when we collect data like this, it will have noises. Certain images, we think that it is laughing images, it may not be laughing image. Certain images, we think that they are talking, but the images may not be talking. Something like that. So some noises will be there. Any sensor data, any type of temperature sensor we take, or any other sensor we take, we have something called noises in the data. So any machine learning, before you try to apply, your duty is to remove the noise. So noise removal is an important component in the machine learning part. In the machine learning, before applying to machine learning, it is your duty to remove all the noises from the label data. And then the next part is something called, very important part, that is called feature extraction. And when you talk about a talking image, the most important part is the lips part. The person or the student's lips will be moving. Or the students who are laughing, again their facial expressions like lips part will be different. Okay, so depending upon the application, there will be certain regions which are very, very important, which will understand the feature. For example, a student is having headache, there the forehead part will be a little bit different, and their eyes will be a little bit different for those who are having fevers and red eye. So the regions which are very important for identifying certain characteristic for machine learning to classify, that part we have to understand and extract the features. Why I am talking like this is, if I am showing the next slide where the features, right? For example, the banana will be having a particular size which will be very different from cucumber, and the banana will be having a particular weight that will be very different from cucumber. The banana will be having a particular width that will be very different from cucumber, but certain times it overlaps also. In the case of students who are laughing, the facial expression here on the types lips, it will be different. So like that, certain type of features we want to extract from the data that we are having. Whatever the experiment that we are going to do, in that experiment we have to do that particular task. It can be even color. For example, cucumber and banana, it can be color classification, shape classification, texture classification. Like so many types of features are there. Including, we say that in an advanced level, those who are not in this particular field, they do have to understand that these features can be converted into another domains like transform domains like frequency domain, wavelength domain, couplet domain. I'm not covering those things, but still there are some mechanism by which we convert these features in a different domain, so that machines will be able to understand in a much better way. And if some sensors are not good enough, we want to have more sensors. For example, a banana which is ripe or not ripe, because it is having different types of minerals in various ripening conditions. And suppose you want to make a agricultural robot which try to capture the bananas, apples or something from the real field. We need different types of sensors which try to understand whether the apple is ripened or not. Okay, how much rigid portion is there, how much non-rigid portion is there, something called total soluble solids, dry matter, acidity content, and something like that. So these type of equipment, sensors are available in the market, which will try to find out the ethylene coming out from the fruit, the carbon dioxide coming from the fruit, and oxygen coming from the fruit. We call this as gas analyzer, which will try to find out whether the fruits are ripened or not. So these type of things will be inside the robot. And this robot will try to go near there and try to classify whether it is ripened or not ripened, whether it is good to pluck from the tree or not. Such type of information will get. These all things are features. This is a sensor that I am showing, one of the example of a sensor. Such type of so many sensors will be there. This sensor will try to find out whether it's ripe or not and try to get the fruit from the very, very, very important feature that we extract from them. And now another example, very clear example to understand why feature is important. Suppose you see this particular part of the eye, whether we are able to understand that person or not is very critical. Now you see this, now again we are not able to understand. Now if you see the nose, certain people will quickly recognize the person because the nose is having a particular feature very different from other parts of the face. If we see the lips, definitely we will understand. It simply means that each and every portion of the image will have some data and information that we have to extract, because that will help to understand the object. It can be cucumber, it can be facial expression, it can be fever, it can be eye problem, it can be tension, it can be the student not able to understand the topic, anything. So the entire face itself, it will be able to provide so much of information. We have to extract each and every information, each and every feature from the thing. That is why we say that feature extraction is very, 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 very important. Now the third component is feature normalization. So we have removed the noise, we have extracted the features. Now the third component is feature normalization. What this feature normalization talks about is different features will be in different range. For example, one feature, for example, Fahrenheit temperature will be 99 degree Fahrenheit to 104 degree Fahrenheit. Suppose we are talking about images. Images values will be from 0 to 255. All the grayscale values will be from 0 to 255. And some other sensor will have a different value. For a machine learning, if you want to learn it properly, we want to make it a common platform. For that, we want to convert the values in, between the range 0 to 1. All the sensor readings has to be converted from 0 to 1, or in a standard range for 0 to 100 or something like that. So that machine learning will be able to better classify or recognize the thing. That is the thing that we want to convey from this normalization. After doing the normalization, I told that so many sensors will be there, most of the applications, and these sensors will give different data. And this data will be so many numbers. So entire features we give to the machine learning, very difficult for the machine learning to learn. So what we do is normally we do a dimensionality reduction, a set of good features which are best enough to classify the student is having fever or not. The set of good features which are able to identify whether the students are laughing or not. The set of good features that will help you to understand whether students are talking or not. So each and every application, the feature set will be different. For that feature set selection, feature selection or dimension reduction is one of the important components. After that only we will normally give it to machine learning. So the machine learning part comes here. Even though we say that once we have a label data, we will be start using machine learning. We will be doing certain different process. Those process will help the data to get well, so that machine learning will be able to learn much better. Then we will finally get something called a trained model. So now after training, once the training part is over, the training part, what we will do, we have label data, we know label data and give the machine learning to learn. Once it is learned, whenever you show a banana, it will show it is a banana. And suppose if the machine learning is trained for predicting whether it's ripe or not ripe, when you show a ripe banana, machine learning will say it is ripe banana. Suppose you show something called a students are laughing image, the machine learning will say that students are laughing. If you show a image where the students are talking, machine learning will say the students are talking. So the first part is training part. Training part is very important, where we have to provide learned data set. And once we provide learned data set and all the machine learning is been learned, we will get a trained model. And here we have the trained model. In the trained model, when you show something a new image, automatically it will try to predict. So machine learning can be used efficiently for predicting, classifying such type of things. Only thing is, initially we have to make the machine to learn. So this is one of the example that I want to show to you. 1 minute. This 1 minute. Yeah, that video I want to just play.
Okay.
1 minute. Okay. Yes. So you can see this video where there is an industrial application. So this industrial application from Japan, which shows that all part whatever I explained to you, you can see that there is a robot which is capturing the chocolates, and you can see there is a system where you can see the chocolates are passing. Whenever the chocolate is broken, it can be a tablet, medical tablet, it is broken, then you can see that it will not pass. So any type of industrial object. It can be a circuit, it can be a tablet, it can be a biscuit. If it is broken, it will not put on the packaging system. It will remove from the packaging. So if it is good, it will put in packaging. So each and every industry, if you go and see where packaging of tablets, packaging of biscuits, packaging of any goods happen, they have industrial objects like this, where behind that there are machine learning. And these machine learning will try to get the images, extract the features, and it will classify it, telling that whether the biscuits are good, whether the tablets are good, or something like that. So this is a real life example that I am showing to you to make you to understand that how actually the industrial application of machine learning works. This is one of the example. Another example that I would like to show is an agricultural piece. So this is also from the apple harvest facility available in the US. So if you see the apple harvest facility in the US, you will be able to see that it is a big industry, fully atomized, with all automation facilities, and in several acres of land. This is the apple harvest available in America. If you go inside it, you can see everything is automized. Okay, so the tree watering is based on machine learning techniques. They will automate it, and the certain types of moving objects throughout the field you can move. There are sensors available which will measure the moisture content, and there are sensors available which will try to find out the soil conditions. There are sensors available which will try to find out the insects that is available, and you can even see the type of robots. I will show the robot which is here, and this robot is having camera, visible light camera, infrared camera, and all the things. So it will go near to the particular fruit and automatically observe whether it is ripen or not, whether it is ready to capture or not, and it will only cut those fruits which are ripened. It can be a tomato, it can be apple, it can be anything. So this is one particular example that I am showing. It's a very big area in which they are cultivating. So this particular equipment is having all the sensors, like whatever I have explained, camera, infrared sensor, whether it's ripen or not ripen, such type of information it will get it, and it will cut from that particular device and put it on the thing. So it's this is the way by which the industry is moving. It means that the machine learning application has it reached even the agricultural field, even classroom it will reach in the future. So that is what I want to convey you and explain you in this particular webinar. Now I am just planning, before moving to the next slide, I just want you to show you a real life example place where you will be able to do experiments by yourself. For example, this is a website, and this website every teacher or every student can take this. This is a teachable machine example by Google. And if you go to this particular website, teachable machine with Google website, students can make experiments by themselves. I will show a real experiment how to do it. For example, I'm just clicking this get started, and once you click get started, you can see projects. Okay, so I am taking an image based project. Suppose I want to take this image based project, and now I asked to two options, right? Simpler one is to make in a embedded device, whether I want to make this experiment or I want to create a small standard model. So I am clicking this particular standard model. So once you get a standard model, this is the place you can see. So this small experiment that we are going to do lively, so that you can see that how beautifully students can learn machine learning, start doing machine learning, implementing machine learning like that. Suppose I want to make sure that students are sleeping or not. Okay, a teacher is not in the classroom. Students are asked to read a chapter. Everybody should read a chapter. One of the students is sleeping. How a machine learning will identify? Suppose I name this class as sleeping, or not sleeping. Suppose I type it as not sleeping. You can type any keyword here, not sleeping, and this class as sleeping. You assume that you are making two different classes. Okay, one as not sleeping and one as sleeping. Very interestingly you do. Now you turn the web camera and record images. Suppose not sleeping means what it will do is I think because of the camera which is already switched on the device, can I switch off the camera for the few minutes and then allow it? I think 1 minute.
So, dear viewers, we are.
Yeah. Okay. Then no issues.
Is it?
So I will show some other example.
Okay, sir.
Because one camera has been used there, I am not able to show this. I will show some other example here.
Please, sir.
Yeah. So I will take a particular thing and can upload some images. Okay.
Okay.
So suppose uploading an image means suppose I have certain images of Apple, for example. I am taking Apple images from the website. Simply you can take like this, and these images you can download and put in a folder. For example, I am putting saving these things in a folder. Save image. If live camera is available, you can do like that. Otherwise, you can put it in some folders. So I am creating a folder.
I would request my team to have that presentation on screen, sir.
Yeah. It is. You are able to see this?
Yes, sir.
No.
Yes, sir.
Yeah. So Apple image, I am storing it here. So
and sir, let me tell you that we have only 10 more minutes left for this session.
Yeah, this everybody can use it.
Okay.
Yeah. So Apple 1. So second Apple, this Apple I am going to take. Save image to second image, and third Apple image I am going to save it. Assume that I am only having 3 images saved. Then saved in Apple folder. Then I am going to have something called orange. I am trying to classify 2 different fruits, and second orange I am taking. I am going to save it in a different folder called orange. So I am going to create an orange folder. Orange, and inside the orange I am having orange 1, orange 2. So many images. Normally in machine learning we need to have hundreds and hundreds of images. For the time being, for the demonstration purpose, I am capturing only 3 images, so that it will be helpful for you to understand. Now going back to the teachable machine, choose image from your files or drag and drop option is there. So you can open it and take the Apple, all the Apple images selected. So now you have Apple images, you can see here. Now you can name this as Apple. Earlier case I was just showing you that we can capture lively from the camera also. And then I am going to take orange images. So you click here upload, and you can choose and drag and drop your orange images there. You select it and put it there. And this is a simple example. Okay, so once you did this, you can now go for training the model. So once you have this, you can start training the model. So many images of Apple are needed, so many images of oranges are needed. So once you train it, a particular machine learning is getting trained there, and it automatically extract the features. It automatically extract all the things needed for it, and then generate something called a model. Now, if instead of this Apple, suppose I have a face like this, I capture it and put it there. Suppose I have faces like head down faces, like whatever I am doing now. That can be on the second. Instead of orange, I can head down images. And in the case of Apple, you can have straight faces. And you can train the model. And after that, you can, if webcam is there, when the student is being faced, automatically it will predict that it is student is sleeping or not. Now in the case of orange, I am going to have a file. Okay, so now what I am going to do is to take a new orange. For example, um, uh, earlier whatever I have taken, I am not taking. I am taking a new orange. Suppose I am going to take this particular orange, save image, and putting as orange one, and going to take another orange, this orange, save image as orange 2. Whether these two things, whether the machine is going to predict or not, we will check it. So we are clicking it here. Then we are taking this orange 2, opening it, and see 100% it has shown that on the bottom you can see 100% it has shown that it is orange. And now I am going to take another image, orange image, this orange image. I am going to ask the machine learning, and now it tells that it is something like look like 50% apple and 50% orange. It is something saying wrongly. Why it is saying wrongly? We have not taught the machine learning with so many apples and so many oranges. Hundreds and thousands of oranges if you give it, hundreds and thousands of apples if you give it, then it should be certain types, certain real life experience we want to do in even in lakhs, 1 lakh images of that type, 1 lakh images of this. Now we will go for an apple and see that whether it is going to show it clearly. Suppose this apple I am going to save it. Save image. I am going to save in the apple folder, and apple 1, save it. And this apple, whether if I upload it on the screen, okay, so this is the apple, new apple that I have taken, and it is saying again orange, right? So why these things happens is the color you can see, color of the apple seems like similar to orange. So it is not always that machine learning will tell 100% all the times. It depends upon how much training data that you use it. Okay, if training data is more, then the machine learning will predict. So this is the example that everybody can do it. And I think if time permits, I can further move forward with other things, or I try to little bit wind it up the sections with few more things.
Sure, sir. So we have 4 more minutes left for this session, sir.
Okay.
In a short,
how many minutes, madam?
in a brief,
5
we would
minutes.
like to know, sir. In a brief, we would like to know, sir.
Yeah, good. Okay. So machine learning is easy for us to implement. Only thing is we need to have so many live examples, need to live images, live data, and other things are needed for a machine learning to learn. And quickly machine learning will not learn. Machine learning will take its own time for learning the things. Once it is learned with so many examples, then it is able to do wonders. It can be for ship identification, oil spill detection, tsunami prediction, weather prediction, kidney stone detection, brainstorm detection, anything, even in the classroom scenario that I was explaining. So many machine learning algorithms are there. Which machine learning? You say you are talking about machine learning. What is a machine learning? This KNN, support vector machine, decision trees, neural network. So many machine learning algorithm. Any machine learning algorithm, depending upon the situation, we can use it. And the latest thing that is happening is in neural networks. Neural network has turned to be one of the biggest achievers in the recent years. Starting from 1943, when the two professors, Michaelis and Pitts, came up with a neuron. This has evolved now into neural network, and neural network will be able to do wonders. And later in 2018, this person has got Turing Award based on his algorithm for training the machine learning. And later in 2024, this again Hinton and again with John Hoffield, two professors, got Nobel Prize, especially for the invention in the machine learning part, especially called neural networks. So everywhere in the literature, when you see now the machine learning has taken a different turn, which we call as deep learning. Certain places we will see deep learning is also a machine learning technique that I want to talk to you because it is a deep learning part, which have several different algorithms. And recently you might have heard about large language models. Behind large language models, deep learnings are there. These deep learnings are nothing but again machine learnings. And generative AI you might have learned. Behind generative AI, it is nothing but LLMs are there, large language models. Large language models again behind deep learning and machine learning are part of that. So everywhere, wherever you see, it is like, for the simplest example, this is one of the exam that I have done in my classroom. I have given this sheet to write the answer for sampling. And what I have given this particular sheet of paper, scanned it and given to ChatGPT. And ChatGPT has given the what is called as mark. It has automatically evaluated that. Within fraction of a second, it will evaluate it and it will give the marks. It means that large language models can also be used inside the classroom for evaluation of answer script, like that. So many applications of large language models. Behind the large language models, machine learning are there. It can be used for question paper preparation, teaching slides, assignments, text consolidation, review of literature, fact finding, exam preparation, doubt clearance, image analysis. So many applications are. So even the smart classroom, when we talk about, it is not a simple smart smart board itself. It will be, as I explained earlier, so many sensors will be there. These sensors will be taking information from the students, data from the students, and we will be able to personalizedly guide the students. I hope that I can wind it up here because time is going. If any other questions are that, I will be able to handle
we are running we are running very short of time right now, so we have to wrap up this session here only. But Rajesh sir, we are very pleased to have you in our live interaction, and thank you so very much for all this valuable information and for this insightful session, sir. Thank you so very much, sir.
Thank you, madam. Thank you all.
Thank you, sir. Pleasure is all ours. And before I wrap up this session, let me share a very important piece of information with you all. In case you want to order 4th or 7th grade new NCERT textbooks, you can order it from Amazon, Flipkart, and from NCERT official website. And before I wrap up, let me tell you about the rest of the programs that we are having today. We will be back with our another live interaction from 2 p.m. and the topic is 𝐄𝐦𝐻𝐸 or 𝐾𝐫𝐢, and this session is for Urdu 3rd standard students, and the rest of the programs are on your television screen right now. So be with us on all these live interaction. Me, Renu Bhatt, is taking your leave, but you stay tuned to PM eVidya channels for more informative programs. Namaskar.